Hi guys, today we're going to make sure you know how to do your calculator 1 for the old stuff, how to do linear regressions, residual plots, things like that, and also to go on today to learn how to do it for exponential models because your calculator is amazing, and we're going to compare the two to see which is a better model, because sometimes things will line up better as a linear or a line, and sometimes will line up better as a curve or exponentially growing or decaying model. So hopefully you recall how to enter your data. In case you don't, just as a reminder, I'm going to zoom out here for a second. Remember, you do stat, edit. Now I've already entered my data. Remember that in list 1 you want to enter your x values, in list 2 you want to enter your y values. And the next thing it asks us is to find the LSRL, or line of best fit. To do that, you go to stat, you go over to calculate, down to number 4, yes, yes, all the way down to calculate. Please do that. Remembering that it gives you the slope and the y-intercept. Since we're doing a linear regression, I'm going to go to the hundredths place when writing my equation for my LSRL. So that would be y equals negative 0.52x plus 15.21. Now, if I want to find the residuals and make a plot, do we remember how to do this? Okay. So I'm going to go to stat, edit. I need to go over to list 3 and I need to highlight L3 and write in my LSRL. Make sure you use the negative button on the bottom of your calculator, not the minus button when entering that negative value. So negative 0.52 from list 1. Remember, list 1 was above your 1 button, plus 15.21. Press down or enter, get lots of values. Now we need to do our observed minus our predicted. So in list 4, this is going to get my actual residuals. Again, notice I'm highlighting the L4, and I'm going to do the L2 above the 2 button on my calculator, and the L3 on my above the 3 button on my calculator. And there are all my lovely residuals, but what it asked me to do is do a general plot, making sure, of course, I label my axes like an amazing student. So here's what we are going to do. We are going to remember how to go into stat plot and make sure everything is ready to go. So to do a residual plot, I'm going to make sure this plot is on. If it's not on, again, no matter what, you can press enter. You can highlight the on. We want it to be a bunch of dots like this. This is list 1 and list 2. This would be a scatter plot, not a residual plot. Hopefully you remember that we need to change the L2 to an L4. And now I should graph it. Why can't I see it? Oh yeah, I got a zoom stat. Zoom, and remember you gotta go down to where it says zoom stat. Oh, now I can see what's going on. So if I wanna do a sketch, I'm going to draw it over here. Remember that the y is always my residual. And this is my x value based on whatever my x was up here. So this is my number of hours after noon, and I'm just going to make a sketch. It doesn't have to be perfect, but it gives me an idea of what's going on. So this says, based on the residual plot, is it a good fit? Remember, we're looking for, does it have a pattern or not? To me, this looks pretty obvious that it's dipping down and coming back up, so I would probably say not a good fit. There is a pattern in the residual plot. But notice this one says, well, a lot of the cooling or heating, which we're doing here, it's melting things, actually works better as an exponential regression. So I'm going to quit out of my graph, and I'm going to make a new equation. We are going to find use the data restoring to find an exponential regression equation. So I'm going to go stat, calculate. What do you think it might look like? Well, let's see what options are here. Exponential regression? That must be it. Again, I still want to use list 1 and list 2. We're using the same data. When we go to calculate, it gives me a and b, and look, here's that equation, y equals a b to the x, like we've seen for all the exponentials. Now, because when we multiply, we need a little more precision, things go out of whack fast, I'm going to ask you to go to 4 decimal places anytime we do an exponential regression. So when I write the equation this time, It's going to be y equals a, again, to 4 decimal places, b to 4 decimal places, to the x. Cool. All right, so again, we're going to find a residual plot. So the first thing I need to do is clear my other data. So when I go back in stat, edit, go up to L4, remember you can press clear, go down. Go up to L3, press clear, go down. Now that gets rid of it and ready to enter your new one. So I go back to L3 and I look at that equation we had here. 15.3766 parentheses 0.9594. Here's your to the, right? Your little caret button. To the, just like before, we don't put X, we put the L1. They'll give us a bunch of data. Same thing, the residual doesn't change just because it's exponential, it's the same thing. So I do L2 minus L3, because I'm just looking at observed minus predicted. And again, it gives me a bunch of stuff. So now I need to make sure, again, let's make sure everything's ready in our stat plot. The plot's on, L1, L4, awesome. So now I'm going to tell it to graph my data again. So the axes label should be exactly the same number of hours after noon. Forgive my poor handwriting. Residual on this one. But what we observe is that this to me is a much more random plot. It might still have a little bit of a pattern, but definitely less than what I observed before. So better, let's write this so you can actually see it. Better fit, residual, plot, more random. So the idea is that obviously this would be better modeled with an exponential equation than a linear one if you're trying to figure out this model and use it to predict other things that were going on.